All right, 4-1 homework. You got any questions that we can, as soon as it warms up here, we can put up on the big screen, and I'll record the answers that we work on and post them. Smart. Way to stay hydrated during math class. Gotta do it, man. Otherwise you get weak. All right. I'm on 4-1. Any of the odds that you worked on that you didn't know how to do? Need help with? Yep. 37. Okay. And what else? 25 and 37. All right. Make sure we get those done here. So 25 and 37. Okay, 25. Use the appropriate arc length formula to find. Okay, I don't like the arc length formula that's listed in the book. All right, they do the whole S equals R theta. That formula only works for radians, by the way. So I like to go with the much more generic one that works for radians or degrees. So question 25. The arc length S is the part that we're trying to figure out. The radius is 2. They said that the angle is 25. Now that they said that's in radians right there. Right? 25 radians. So what should I be using in the denominator? 2 pi, because that's the entire circle in radians. And then, of course, we have the 2 times pi and theta, and the radius is 2. Now, if you're only dealing in radians, that's why their formula works, S equals R theta. Because the 2 pi's are always going to cancel out if you're in radians. Not true when we get down to degrees. So what do you get? 50, right? 2 times 25. While we're on that, any of the other ones in that list? Was 31 okay? Or okay, well, which one did you have in there?
It was 29.
29, okay. We'll get down to 37. I won't forget. Well, thank you. Is there anybody else out there printing? If you're the last one, you kick the block out so we don't die. That's right. Take care of us. Question 29. We've got an arc length of 3. We don't know what theta is. I'm going to use the Greek letter theta. Yes. I don't know if you're familiar with theta. Are you familiar with the Greek letter theta or not? Okay. You're going to see it a lot this semester, so you might as well get used to it. Okay, and we're talking 2 pi radians and 2 pi times the radius, which is 1. And yes, I know. The 2 pi's cancel out. What does that mean about theta? Theta is equal to 3 radians. Now that's not 3 pi radians. It's just plain old 3 radians. It's a decimal equivalent of radians. I got a question for you. Is that bigger than 180 degrees or smaller than 180 degrees? Okay, you got about 20 seconds to talk to your neighbors and figure out whether you think that angle is bigger than 180 degrees or smaller than 180 degrees. What do you think? I gotta vote for less. Yeah? How do you know it's less? 2 pi is what? 2 pi would be 360, right? So 1 pi would be 180. What's the decimal approximate for pi? 3.14. That's why we know it's a little bit less than 180. I just kind of want to get the connection in your brains that this is a tad bit smaller than a 180 degree angle. What? Correct. You would be close. Right? That's another way to handle it. Since we already calculated that 1 radian was about 57.3 degrees, that's a good strategy too. Yeah. Okay, anything else in this range before I bump down to 37? Yes. 33? Sure. We'll jump down there. A central angle theta intercepts arcs S1 and S2 on 2 concentric circles with radii R1 and R2. Find the missing information. Okay. So we basically have 2 theta's the same, but we have 2 different arcs, or 2 different radius and 2 different lengths of arcs. So radius 1 is 11, but radius 2 is 44. Not drawn to scale, folks. That's how they got away with murder in geometry class, right? You could draw it however you wanted to. All you had to do is slap a phrase on there, not draw to scale. That's basically what I just did. I mean, obviously the second one is not 4 times as long as the first one. Anyway, just thought I'd tell you that. Okay, so we don't know what the last one is, and we don't know what the angle is. So I'm guessing that I'm going to have to use the first one to find the angle. Then I can use that information to find the second arc length. Okay. And would you like to do it in radians or degrees? Degree? Okay, let's do degree. That's my favorite deodorant anyway. It's good stuff, really. Okay, so theta over 360 times 2 pi times 11 equals 9. Okay, I'm using the first set of information to figure this out. All right. Any thoughts? Any way that we could reduce on the right side before we do anything else? Oh yeah, 2 goes into 360. How many times? 180. So now we have 9 equals theta times 11 over 180. Now what? Yeah, you're looking at a proportion, folks. And how do we handle all proportions of the universe? We cross multiply. Now, in middle school, we also talked about things like multiplying by the reciprocal, or at least in your Algebra 1 classes. Multiply by the reciprocal on both sides. So we could do it that way. That's the same. It's cross multiplying, folks. That's all it is. You know, and if you want to do it one step at a time, you want to multiply by 180 and then divide by 11. It's okay to do it that way too. Let's see here. I'm not going to be able to do that in my head because dividing by 11 is not going to be nice. So, a little bit better reach for a machine. I need to get a pistol grip for this thing and a holster. That way I can walk around, look cool, you know. Officer, I promise, it's just a calculator. Never mind. Where's pi? Is this a trick question? Oh, you mean on the calculator?
No. Did you cancel out pi?
Oh, I forgot. Good question. Thank you for catching my mistake. That is awesome. Okay, you cannot always see that one of the more important things that you can learn from any math class that you take is that you really need to pay attention because everybody makes mistakes. Nice job. Would we be multiplying by pi or dividing by pi? Multiplying by pi or dividing by pi? Which one? You'd be dividing, right? That pi would be in the denominator down there. So that's another good reason for me to use my calculator. Whew, 180 times 9. Oops, can't type. All right, so that's 1620. And divide that by parenthesis 11 pi. If I don't use parentheses, I'm probably going to get it wrong. So 46.9 is our angle measurement. Just make sure if you are typing this on a calculator that you use the parentheses around that denominator or you're going to get it wrong. So then your angle, once you have your angle, then you could do the other part, right? All you're going to do is repeat the process using the 46.9. 46.9, I don't have enough room. 360, 2 pi times e. Oops, not 11. What would it be? 44, thank you very much. Okay, remember that whole thing's over 1, just in case you were wondering. And then you can take that number times 2 pi times 44, and then divide the whole thing by 360. I got a 36. Well, that's interesting. We went from a radius of 11 to a radius of 44, and an arc length of 9 to an arc length of 36. Do you see any connection? It's proportional, isn't it? Why? What do you know about the relationship in the formula? What kind of function is it? I'll give you a couple options. Do you think it is linear? Do you think it's quadratic? Do you think it's cubic? Do you think it's a square root? Do you think it's a log function? Exponential? What do you think that thing is? Something times 2 pi r. What's the exponent on r? What kind of function is it? Linear, which means that the part in front must be the slope. So if you're multiplying 1 by 4, the other one gets multiplied by 4. Oh, so it's not, yeah, that's kind of cool. Making connections with pre-calc, it's awesome. I know you thought you could forget it, but you'll never be able to get away from it. 37. It takes 10 identical pieces to form a circular track for a pair of toy racing cars. If the inside arc of each piece is, ooh, this will be interesting. Inside arc of each piece is 3.4 inches shorter than the outside arc. What is the length of the track? 10 identical pieces to form a circular track. Inside arc of each piece is 3.4 inches shorter than the outside arc. Okay, so what's the difference? So we've got circumference 1 and circumference 2. What's the difference between them? Ten pieces, and the difference of each piece, like if that's one of the pieces, the difference of the inside edge to the outside edge is 3.4. Maybe this is not useful. There's 10 sections, folks. That means the difference between the circumference would be 34. Maybe I just need to focus my attention on one of these pieces and look at this like we just did with one of the other questions. What's the central angle in that piece right there, this part in green? 36 degrees. Where did you get 36 degrees? It's 10 pieces, right? 360 divided by 10 pieces makes each one of those angles 36 degrees. Okay? So we have, I wonder if we're just supposed to pick a random value. Or if we're supposed to say something like this is x and this is x plus 3.4. Because that would make this kind of an ugly question. Because we could find, so 36 over 360 times 2 pi x, that's equal to 1. Oh, no. X is not the radius. In my diagram, x would be over here. We don't know what the radius is. But then the other one, x plus 3.4 equals 36. This is still not going to, I'm going to have to think about this one and come back to it. Because this has got two different, I'm trying to find what's the common connection. If I have to use x and then connect these two formulas by some sort of substitution, it might get a little ugly. I'll come up with a better strategy on that question and show you that one. So pause that one for station identification. Because I want something better. That looks, the way I'm doing it seems ugly to me. Seems like there should be a better way. Sorry about that. I'll come back to you on that one. Well, it looks, it just doesn't seem like they've given us a simple way to do this, so I might have to get a little creative. And there's got to be some nice way to handle this.